All right, you guys, I'm just going to work through each problem on this review. Feel free to pause, rewind, fast forward, put me at double speed so it's not so long. But we're just going to work through each one of these. So here we go. Number one, what is the definition of a function? Okay, so remember, a function is when every x has exactly one y, right? So I'm just going to kind of write that, right? So every x, or input, if you want to write it input, every x has exactly, that's a weird look, it has. Exactly one y, or output, right? So there's only one y for every x, okay? So for example, I'm just going to do an example. So let's see, I'm going to make it. So a function, so an example of a function would be like if I put in a 2 and I get out a 5, then I put in a 3 and I get out a 7, right? That's a function because I have two different x's giving me two different y's, right? An example of not a function, right, would be if I put a 2 in and get out a 5, and then I put another 2 in and I get out a 7, right? That cannot happen. I can't put in the same x and get two different y's, okay? So remember, no repeating x's is what we're looking for, okay? All right, what is function notation, right? Function notation is just when it says f of x instead of y. And hold on real quick, let me put f of x equals, because it's got to be like that, right? So it says f of x equals instead of y equals, right? That's all function notation is, right? It tells you what the input of the function is with the f of x, and it names it, right? And it could be g of x, h of x, k of x, it doesn't matter, right? It just names the function and tells you what the input is in that parentheses. Okay, I'm going to go ahead and just write that really quick. So remember, the letter in the front is the name. It can be any letter at once. And then the x is your specific input. If you just write x, then you're talking about all possible x's or the domain of the function. If it said f of 5, then they are specifically wanting you to plug a 5 in for x and give the output for just the 5. Okay, if it just says f of x, then it's talking about the whole function itself. All right, what does it mean if you're asked to evaluate something, right? So that means to substitute a number in for a variable. And usually in simplify, right? You're plugging a number in and then answering the question, right? So to evaluate means to substitute a number in for a variable and to simplify. For example, if I gave you the function y equals 2x plus 3, right, and I told you that x equals 4, well, then you would substitute x equals 4 in for the x, and you would rewrite the whole thing again, y equals 2, but you always put the number in parentheses that you're substituting, always, right? So we take the x equals 4 and we plug it in for the x in that expression. And then you simplify it as much as you can. Can I do 2 times 4 plus 3? Yes, that's going to give me 8 plus 3, which is 11, right? And that would be my answer when I evaluate y when x is 4. Okay, so that's all that means. All right, number 4, compare and contrast discrete graphs versus discrete graphs. Okay, so let's see, discrete, I'm just going to describe discrete graphs, and then continuous. There we go. So remember, discrete graphs is dots, okay? So it's just individual points. Okay, they are not connected. not connected, right? It's a broken graph. You would have to pick up your pencil in order to draw it, right? So an example the graph would look like this, right? If I had to graph some just like right? That is a discrete graph, right? And the reason why it's broken typically is because we cannot include the fractional values of things, right? It's not connected because we can't include the fractional values. Let me just add that up here, sorry. Not connected because we can't use the fractions, right? Because if we connect the dots, right, if I were to connect these dots, that means I'm including all the infinite decimal and fractional values that exist between the dots. And for some reason, I don't want to, right? Because I'm talking about the number of shirts that we're buying, and the number of candy bars that we're buying, right? We're talking about something that is specifically a whole number in nature and can't be a fraction, okay? Then we have continuous graphs, right? So continuous graphs are connected, okay, which means lines, curves, etc. Right? It doesn't matter if they're lines or curves. It could be loop-de-loos, right? It doesn't matter, but it's connected and you can draw it with one swoop of your pencil, okay? And we connect the dots because we can use the fractional values, right? So if I have those same 4 points, right, maybe my graph looks like this, right? And then maybe it does some weird, curve, right? So if my graph looked like this, right, that would be continuous. And maybe I have an arrow on an end, maybe I don't. It doesn't matter if there's arrows. It's just the fact that there are infinite dots making up this graph, and they're clearly being connected by lines and curves. That's what makes it continuous. There's no break in the graph where I have to pick up my pencil, okay? All right, number 5, when will I see a common difference, right? So we just talked about this yesterday, right? A common difference is, I'm just gonna say when you have an arithmetic sequence. Right, so remember I'm just gonna write the subscript notation that says that any term can be found by looking at the term before it and then adding some common difference, right? So the common difference, remember, is the letter D in the formula, okay? So for example, let me just run through this really quick. Sorry, I promise I won't be this long-winded on the rest of the problems. All right, so let's say I had the sequence 2, 6, 10, 14. Well, how did I get that sequence? Well, I took the term before it and I added 4 to get the next number in line. Then I added another 4 to get the next number in line, and so on and so forth, right? So my common difference is 4. Oops, sorry. Right, this is my common difference, the plus 4. All right. Oops. Sorry, I was trying to draw a nice pretty arc. There we go. All right, so that kind of takes care of all of our kind of fill in the blank type questions. Let me scroll back up here, number 6. So it says plot the following points on the grid. Okay, most of you guys are great at this. Some of you guys struggled with this a little bit. Please remember to find your X and Y axis and make sure you know exactly where those are, right? Because this is 0, 0, the origin right there in the middle. And that's where we start counting every single ordered pair, right? So remember, every ordered pair is X, comma, Y, right? So X, right? X tells you whether you're moving left or right from the origin. And then the Y is telling you whether you're moving up or down from that point, from that position, right? And so that's the Y, that's the vertical movement, right? So if your horizontal movement, you move right if it's positive, left if it's negative. Then you apply the Y coordinate, you move up if it's positive and down if it's negative, okay? So I'm just gonna plot these really quick. I'm going to put letters with them so we don't lose track of where they are. I'll try to use different colors here. Here we go. So A, I'm just going to call that point A, is at negative 1, 5. Well, that means right 1, up 5, because they're both positive movements. So I'm going to go right 1, up 5. 1, 2, 3, 4, 5, and that should land me right here. So I'm just going to label that point A. All right, and then point B, negative 2, 5. That means left 2, up 5. So that's going to land me right here. C, our next one is negative 3, negative 2. Those are both negative movements. So that means left 3, down 2, which is going to land me right here. Remember, you start from the origin every time. Left 3, down 2. All right, then point D is at negative 4, negative 1. That'll be in the same quadrant as C because they're both negative. So left 4, down 1. That puts us here. All right, and then E is at 0, 5. These are the ones that tend to get missed the most. So remember, the 0 means you're not moving left or right at all, and the positive 5 means you're going up 5, right? So if I don't move left or right anywhere from the origin, I'm just going straight up 5. That means I should be on the y-axis, right? That's my point E right there. Okay, then F is negative 1, 0, which means I'm going left 1, but then not up or down at all. So I'm going to stay on the x-axis since the y value was 0. Then we have, I already used that one. Let's see, E, F, G, right, at 0, negative 3. So again, remember the 0 means no left or right, only down 3. So there is G. And then our last one is 5, 0. All right, so I'm going to call that H. And that means we're going right 5. 1, 2, 3, 4, 5. And then I'm not going up or down at all. So that's where I'm going to, oops, so sorry. That's where I'm going to land for my H. Okay. All right, plotting points. All right, here we go. List the coordinates that are graphed below. Okay, so this is the exact opposite, right? We give you the graph, you give us the coordinate. So here we go on number 1. Remember, everything is from the origin, right? So it looks like we're going left 4. That's negative 4 because it's a left movement. And then up 1, 2, 3, 4, 5. So left 4, up 5. And up is a positive movement, so negative 4, 5. Okay, let's see, 2. Looks like we're going left 1, which is a negative 1 movement, and down 2, which is a negative 2 movement. All right, now 3, be careful. On 3, from the origin, we are moving right 1, but we're not moving up or down at all. And right is an X movement. So the 1 goes in the X position, and the Y coordinate is 0 because we're not getting any height, right? The Y is not getting moved. And then our last one is point 4. It looks like we're moving right 4. Oops, sorry, 5. 1, 2, 3, 4, 5. Right 5, sorry, and down 1. So right 5 is a positive 5 for the X, and down 1 is a negative 1 for the Y. Okay. And by the way, if your axes are not labeled, please label them so you don't get lost if it helps you, right? I mean, the X and Y axis were not labeled in this problem, right? But if it helps you to get your movement and your bearings, then write that in yourself, okay? All right, next page. List the domain and range for the following relations and determine if they are a function or not. All right, so we've done this lots, right? You guys were really good at discrete data. Remember, this is discrete. I'm going to go ahead and just write that, even though it doesn't really ask me for it, right? This is clearly discrete data because my data is only made up of these 5 points and only those 5 points. Nothing tells me to connect the dots or anything like that. Okay, so remember, domain is all your X's. Well, this is discrete data, so that's just going to be a list of X's. And remember, please don't list them just in the order that they're written. Remember, anytime you write domain and range, it's in numerical order with no repeaters. Now, I don't have any repeating X's, so I'm just going to write them in numerical order, right? So 1, 3, 4, 7, and 8. And then we have our range values, which are the Y's. And right away, I noticed that I have repeating 2's, but remember, when you write your range, you don't write repeaters. And that not only is I have repeating 2's, but it's my least number. So I'm going to put 1, 2, and then 7, 8, 9. And guys, use those highlighters, right? Use them all over your tests, right? Like we've been doing in our notes and homeworks, right? It will really help you visually. All right, is this a function? Yes, it is a function because as we said, there are no repeating x's, right? And that's just what I'm going to write for my reason. When it says y, right, no repeating x's, or every x has a single output, okay? Remember, it's okay for the y's to repeat, right? I don't care that I put in a 1 and get out a 2 and then put in a 7 and get out a 2. I don't care about that because it was 2 different x's that were used, right? I just can't have the same x give me a different y, okay? All right, let's look at B. Let's see. I'm going to try to use the same colors. It's green. All right, so again, basically the same thing, right? Here's my domain. Right, so let's see, only 2 numbers exist because the negative 3's are repeaters, but I don't want to write the repeaters, but I am going to put it in order from least to greatest. And then our range, right, again, least to greatest. I guess it's already written in least to greatest, so I'm just going to bring that down, negative 3, 2, and 7. Right, is this a function? No, it is not a function. Right? Because the x's repeat. And you can be more specific if you'd like, right? You can say x equals 3 repeats. Here, I'm going to write that. I'll just be more specific. So x equals negative 3 repeats. And if you don't want to say repeats, you can say it gives you 2 different y values, right? I can't put in a negative 3 and get out a negative 3, and then in the exact same relation or function, put a negative 3 out and get a 2, right? That can't happen, okay? So x equals negative 3 repeats. That's not good. All right, let's see. This is the exact same thing. It's just written as an XY table instead of a list of ordered pairs, right? But it's no different, right? Your domain, right? It says domain at the top, but remember domain is just a fancy word for all the x's, right? And then it says range at the top, but that's just a fancy name for all the y's. All right, so let's see. It looks like our domain, oops, let me change colors, right? Our domain is 1, 2, 3, 4. And it looks like our range is just 5, right? No matter what I put in for x, I get out a 5. Is this a function? This is kind of a tricky one, right? So you got to think about it for a second. The answer is yes. This is a function. Now, some of you guys might have initially put no because you have repeating 1's, but it's not just if the 1's repeat. Remember, it's if it gives you 2 different outputs, but notice they just wrote the same point twice. Now, normally no one would ever do this because obviously I'm not going to plot the same point on top of itself. They're literally just putting this in the table to trick you, right? So as long as I put in a 1 and I get out a 5, if I put in another 1, I have to get out a 5, and that's what's happening. So this is a function, right? So I'm going to write no repeating x's. And I'm going to put in parentheses with different y's because that's what we're talking about. Normally when we see repeating x's, we have different y values attached to them, but this one's just trying to be really tricky. So don't fall for the trickery, okay? All right. Oh, you know what? Let me keep those. Let me keep that there. There you go. So if this was like a 6, then this would not be a function, right? Because I can't put in a 1 and get out 2 different y's, right? So just want to make sure we're clear about that. All right, back to the top. Oh my goodness, there's a lot of these. All right, again, input, again, which is just another fancy name for x's. I meant to write that in green, right? And then we have our y's, which is another word for that is outputs. Right? All right, other than that, basically more of the same, right? Domain in numerical order, -5, -4, -3, -2, -1. Right, and then our range, be really careful, right? Don't just write it in the order that it's written in the table, because range and domain is always least to greatest. So I know we went from top to bottom over here, but we have to go from bottom to top on the y side because it's the least to greatest. So 1, 2, 3, 4, 5. Is this a function? Yes, it totally is a function, and it has no repeating x's. There's no trickery here. No repeating x's. Okay. All right. This guy is a mapping, right? We like mappings because the domain and range is essentially already done for you, right? And so remember, highlighting, right? Remember your x's. So these are all the x values, and they're already in order from least to greatest with all the repeaters taken out, right? And then we have all of our y's already in numerical order with repeaters taken out, right? So that makes it nice and easy. So literally to do domain and range, I just have to literally copy what's in the bubbles. 0, 1, 2, oh, that's an 8, sorry. And then of course the range, -3, -2, 2, 3. Now, is it a function? Well, what I'm looking for is, are any of these x's used twice? Meaning, is there more than one arrow coming out of them? So like this 1, the -1, I mean, he only has one y attached to him. The 0 only has one y. The 1 only has one y attached to him. The 2 only has one y, and the 8 only has one y. So none of the x is repeated, right? Because they only have one line coming out of each one. If one of them repeated, like for example, if there was another line coming out from the 8, and so there was like a double line like this, then this would be not a function, right? Because I can clearly see the 8 has been used twice to get 2 different y's, okay? But that's not happening, so that's why this is a yes. Okay. And again, you can just say no repeating x's. But you definitely need to know what to look for in the mapping. Okay. All right, looks like we have one more, and it's a mapping. So again, domain and range, pretty quick and easy with mappings, right? So these are already all my x's from least to greatest. These are already my y's from least to greatest. So I literally just have to copy them down, throw some in curly brackets in there. -2, 3, 4, and 10. And then my range, -1, 0, 2, 4, 6. Now, is this one a function? No, absolutely not. And which number is causing it not to be a function? This guy. Look at that 4. He's being used 3 times. He's got 3 lines. So if we were to write coordinates, that would be 4, 0, 4, 2, and 4, 4. I'm putting in the same x and getting out 3 different y's. That's like a horrible failure of being a function, right? And so we're looking for more than one line coming out, right? So I'm just going to say x equals 4 repeats. If you just want to write the x's repeat, that's okay. I'm just being more specific and just talking about which number is causing the problem. Okay. All right. Let's move on. I think we've just about killed the concept of discrete domain and range there. All right, here we go. Number 9, use the domain of x equals -3, -2, 5. So this is 3 different x values. To evaluate, so remember we talked about this earlier, evaluate means you're plugging in numbers. To evaluate the function f of x equals 7 minus 4x. Okay, so remember function notation. This is just called the f function, and this variable right there is just telling you what the variable is on the other side, right? If this, sorry, I'm just going to scribble. If this was a y, oh, that's a bad example. If this was a w, then this would say f of w, okay? If this was a p, then it would say f of p, right? So literally that's just telling you what the variable is on the other side. That is its only purpose of f of x, okay? okay? So remember, if they give you 3 different x's, this is a 3-part problem, okay? All right, so here we go. All right, let's see. I'm going to do the first one. So the first one is going to be, sorry, I'm going to try to highlight here so we can keep track. I'll do pink. So we're going to do -3 first. So I'm going to write this as f of -3, because that is the specific x they want me to plug in. And then 7 minus 4 times -3. So all I'm doing is substituting that value in for x. And then I'm going to bring down my f of -3. Remember, this is just a fancy y. If I wanted to write y equals, I could, but it's function notation, so it's just fancied up, and they're writing f of -3 equals, and then you just do the math over here. So that's going to give me 7 plus 12, which is 19. Please use your calculator if you need to. Okay, so when I put in a -3, I got out a 19. All right, now we just need to do that 2 more times. All right, so now I'm going to go to my next x value, which is -2, right? And I'm going to plug in f of -2 equals, and I'm going to rewrite my function and substitute the -2 in, 7 minus 4 times -2. All right, so here's my -2 that I substituted in. So now f of -2, again, I'm not doing anything with this stuff. That's just a fancy y. That does not mean f times -2 or anything like that. Let me fix that. It's just a fancy way of writing y equals, what's that going to give us? 7 plus 8, so 15. So when we put in a -2, we get out a 15. All right, now we just get to do that one more time because we've got our third and final x value of 5. So now I'm going to go find f of 5, which is 7 minus 4 times 5. Again, I'm doing the same thing over and over and over again. I'm just plugging in a different number for x. And use your calculator if you need to so you don't make a silly mistake. That's going to give me 7 minus 20, which is -13. All right. But you're not quite done because it wants you to write the range. Well, the range is all of your outputs that you just got. Well, we just got 19, 15, and -13 as our output values when we put those x's in. So now you just need to write that in range format. Remember, every time we write range, it's in order from least to greatest. It's not written in the order you did the problem, right? I got a -13. He's the smallest value, so he goes first, then 15, then 19. Right? And that's where all these numbers are coming from. Okay? All right, I spent a lot of time explaining that one, so I'm going to kind of fly through the rest of these function notations pretty quickly. Let's see. Number 10, evaluate the function, this big long thing right here, f of x, for f of -3. And again, this is just whenever you see this, that does not mean f times -3. No, no, no. That means to go find the f function, oh, here it is, and substitute a -3 in everywhere you see an x. And then work out the problem, right? That's all that means. It looks complicated, right? But it's not. Right, so f of -3, I want to be specific. You can write f of x if you want to, but I'm telling my reader exactly what number I am plugging in for x. So I'm going to rewrite all of this, but I'm going to put a -3 in everywhere I see an x. Now, this one is very tricky because I've got a negative and I've got all these x's. Please make sure that every time you insert a value in for x, that you put that number in its own little personal set of parentheses. It is so, so, so important. So when I rewrite this function, I'm going to bring down the negative, and then I see an x. So I'm going to put a -3 in his own little set of parentheses, and then the square goes on the outside. Only the -3 should be in the parentheses, nothing else. Then I'm going to bring down the plus 2 and then times x, but I'm going to put him in his own little set of parentheses. And then I'm going to bring down the last plus 2. Okay? Everywhere you see an x, your number gets its own little set of parentheses. Okay? Now, if I were you, I would just type this verbatim into your calculator. You can work it by hand, though. It's order of operations. Just don't mess that up because this is positive 9, but the negative in front of it makes it a negative 9, right? Minus 6 plus 2, right? And all that should give you negative 13. Again, use your calculator, right? Or at least check it, right? I'd love it if you did it in your head first, right? And you tried to use PEMDAS and did it in your head and then checked it with your calculator. That would be amazing. All right, and then that's my answer, right? This was just a one-step problem because they only gave me one x value to evaluate, as opposed to this one up here where they gave me 3 different x values to evaluate, right? That was a 3-part problem, but this is just a 1-part problem. All right, number 11 is very much like number 9, right? It's the same exact thing. They're giving you an f function, and they gave you 3 different x values. So I'm going to do the exact same thing I just did a second ago, right? I'm going to take the negative 2, and they're telling me to substitute that in for x. And I'm going to do them one at a time. So here we go. F of negative 2, negative 3, parentheses, put him in his own little set of parentheses. And what's that going to give us? 6 plus 6, so 12. So when I put in a negative 2, I get out a 12. That's what that function notation is telling us. Okay. Again, please don't just write 12 and box it up. Remember, there should be no naked numbers, right? What's 12? Oh, f of negative 2 is 12, right? You should always have a context to every single answer in this class, right? And not just random numbers floating around on your paper or boxed up on your paper, okay? All right, now I'm going to plug in negative 5. I'm going to do the exact same thing, but now I'm going to put the 5 in for the x. So f of 5 equals negative 3, parentheses 5. And then I'm just going to bring down the f of 5 because that's my fancy y equals, and that's going to give me negative 15 plus 6, which is negative 9. Again, use your calculators if you need to. You're just plugging numbers in. And then lastly, we have a 10. Oops, I have a double dot there. There we go. And we're going to do the exact same thing. Now we're going to take the 10 and plug it in for x. So f of 10 equals negative 3 times 10 plus 6. Bring down my f of 10 because that's just a fancy y equals. That's going to give me negative 30 plus 6, so negative 24 should be my output when we insert a 10 for x. Okay. And then, of course, it wants you to find the range. Well, if I put in 3 x's, I'm going to get out 3 y's, right? It's just a matter of putting them in order from least to greatest and writing my range properly. Right, so it looks like negative 24 is the smallest output, then negative 9, then the 12. All right, so just taking all of our answers. Okay. All right, moving right along, back up here to top, number 12. All right, determine if the graphs and word problem below are continuous or discrete. Okay, let's see. Oh, and then it asks you also for the domain and range. Okay, that's fine. Okay, so on A, clearly this is a continuous graph because it is not just a series of dots, right? Discrete just means points, right? Continuous means connected by lines or curves, okay? Remember domain and range, right? So we're looking for the walls, right? So is this graph allowed to go forever left? Yes, there's an arrow going forever to the left. Is he allowed to go forever right? Yes, because there's an arrow that tells me he's going forever to the right. So I have no walls or boundaries for the width or the x's of my function, which means my domain is all real numbers. Put that in curly brackets. There you go. You can actually write out all real numbers if you want to. Now the range, right? The range is our height of our graph from low to high. Is this graph allowed to go forever down? Yes, because this arrow is going forever down. Is he allowed to go forever up? Yes, right? So he has no height boundaries. So his range is all real numbers. If you cannot draw any walls because your function isn't stopping anywhere, then the answer is always all real numbers, okay? All right, this one is clearly a discrete graph because it's just a series of points. And your job is to go find the domain and the range. Now, this is kind of like lots of walls, right? It's like you start and stop. Like I start and stop here. I start and stop here. I start and stop here and here and here, right? So you need to name all those X values. If it helps, you don't have to do this, but please write the ordered pairs off to the side if it helps you so you don't get confused, right? Like this point right here, what is that? 1, 2, 3, 4, 1, 2, 3. That's the point -4, 3, which means his domain is -4 at that point, and his range is 3 at that point, right? The X's are the domain, the range is the Y's, right? So if it helps you to write the coordinate down, please, please do that. This point right here, he's -2, 0, right? Let's see, keep going. This point is 1, 2. Right, over 1, up 2. Okay, let's see, I'll go to this point. What is he, 2, -2? And our last point, 1, 2, 3, 4, 2, it looks like. And I think that's all of them, right? It's only 5 points, 1, 2, 3, 4, 5. Yeah, that's all I'm saying. So when you're writing your domain, all I care about is just the X values that these points are taking on. Right, so I'm just gonna, and they're gonna go from least to greatest, and I'm just gonna list them down. -4, -2, 1, 2, 4. And mine are already least to greatest because I read my graph from left to right, right? So the domain is naturally already gonna be in the right order. Now the range, not so much, right? Because it's hopping up and down everywhere. But I do see my range values, right? And I need to make sure I put them in order from least to greatest with no repeaters, right? So we're going bottom to top. Right, remember floor to ceiling. So I hit the -2 first, then I hit the 0, then I have 2 2s, but I don't use repeaters. And then the 3 is our highest Y value that any of these points take on. All right, so that is our range. All right, next graph. A pizza store sells pizza by the slice. Your total depends on how many slices you buy. Each slice is $3.25, right? Is this discrete or continuous? Well, it says it's by the slice, which means they are not allowing you to be like, I don't want a full slice. I just want a third of one, right? Well, that's not allowed, right? So this is discrete. Right, so this is discrete, right? You cannot buy a fraction, or I'm just going to put, you can pick any fraction you want. Can't buy half of a slice. Or you don't have to pick a half. You can pick a third or a fourth, or just say you can't buy a fractional slice of pizza. Okay. All right, moving right along. You're trying to get in shape and you've begun running. The number of calories you burn depends on the distance you run. For every mile you run, you burn 125 calories. All right, so I want you to think about graphically what this means, right? So the amount of calories you burn depends on, oh my gosh, look at that, oh so awesome phrase, depends on, right? Remember we talked about this so much in class. That means, remember, Y depends on X, right? So the calories you burn has to be the Y. Right, so the calories you burn depends on the distance you run. So distance is your X. Now I know it doesn't ask you to graph that, but if you want to figure out if it's continuous or discrete, remember that is always based on the X. That looks like I shouldn't highlight that. Right? This continuous or discrete always is based on the X. I don't care about the Y at all, right? The Y is dependent, right? He's going to depend on what I put in for X. So it all depends on the X. So can I run, It doesn't really depend. Oh, it says for every mile. There we go. Can I run half a mile? Sure. Can I run a third of a mile? Yes. Can I run 6.2795 miles? Sure. Right? So this is definitely continuous. Right? Because I'm just going to say you. So you can run fractions of a mile. Or if you just want to use 1/2 as the example, you can run half a mile, you can run a third of a mile. I would totally take that as well. Okay. All right, list the domain and range of all these graphs. Okay, this is literally what we've spent the last couple days talking about. We just took a quiz on this, right? And say, here we go, domain and range. So find your graph. So here's our graph over here. I'm going to highlight it because he's kind of sneakily over here. He's this vertical line. So you want to ask yourself, are there any walls? Actually, I feel like maybe that's confusing if I highlight that for you guys. So domain and range. So domain, does he go forever left? No, he's not even allowed to go left at all because he's a vertical line, and he's not allowed to go right at all. So he kind of is his own wall, right? He can only take on that x value, 1, 2, 3, 4, 5 of -5. So his domain is just -5. It's not an inequality because it's not anything less than or greater than -5. It's literally just -5 because it's a vertical line. That's the only value he's allowed to be. Okay. Now for the range, right? The range, is he allowed to go forever down? Yeah, because there's an arrow going forever down. He's also allowed to go forever up. So I have no walls restricting the height of my function. So that means his range is all real numbers. Okay. All right. I'm going to use a lot of highlighter here. All right. Domain. Well, this is a discrete graph. So again, if it helps you to write the points off to the side, you totally can. If you don't need to do that, that's great also, right? So my domain, did I use green? Yeah. So my domain is going to be the x values of all these points. So this x value gets used, this x value gets used, this x value gets used, and this x value gets used, right? I'm just kind of following my points to the x-axis, right? And seeing what those x values are from left to right, because I want to do things from least to greatest. And because he's discrete, there are no inequalities because I'm not using any fractions. 1, 2, 3, 4, 5. So it looks like -6 is my first x value. And then -3, and then 1. And what is that, 4? Okay. And then we have our range, which is our y values. So I've got this, oh, sorry, I meant to change colors. We've got this y value. Remember, we're going low to high. This y value, this y value, this y value, and this y value. All right, so I'm just looking at the y values of those points. Again, if this, well, let me just write that down really quick. So from low to high, let's see, 1, 2, 3, 4. So -5, right? This is our lowest y value right here at -5. And then we have this guy who has a y value of -2. Then we have this point, which has a y value of -1. Then we have this point that has a y value of +1. And then we have the very top point, 1, 2, 3, 4, and he has a y value of 4. Okay, so least to greatest, right? Floor to ceiling when you're doing the y's. Again, if that confuses you, please just start writing out the ordered pairs. Like, oh, this point is -6, 5. Wait, hold on, 4, sorry. Not 5, right? He's -6, 4. And so I have to have a -6 in my x, and there has to be a 4 in my range, right? And you can just kind of do that for all the coordinates if that helps you, other than reading the graph, okay? Basically the exact same thing I did right here, right? Instead of reading the graph, I wrote all the points down and I used the points, right? Same thing. All right, sorry, let's see, back up here at C. Okay. So on this one, right, we are doing domain and range again. Is this graph allowed to go forever left? Yeah, because there's an arrow going forever left. Is he allowed to go forever right? Yep. So he has no restrictions left or right. So that means his domain is all real numbers. Okay. Now we ask ourselves for the range. Does he have a restriction to his height? Well, is he going forever up? No, he doesn't even get to go up, sadly. He's just stuck right here in this horizontal line, right? So he's not allowed to go up or down. He's just stuck right here at this y value. And what is that y value? 1, 2, 3, 4, 5. So he's just stuck at y equals 5 for the rest of its life, right? So that is his range. It's not an inequality because there's no walls, right? He's just 5 forever and ever and ever. All right, let's go look at this guy. He definitely has walls. I don't see any arrows. Please don't put your own arrows in. You're not allowed to do that. So let's talk about domain. He's definitely not allowed to go forever left because he is stopped right here. And he's definitely, let's go find that x value. What is that x value? 1, 2, 3, 4, 5. Let me zoom in. This is negative, let me write darker. Negative 5 is that x value. And then he's trying to go forever right, but then he hits another wall, right? And he hits a wall right here. And that wall, 1, 2, 3, 4, has an x value, let me zoom in, has an x value of 4. So this graph is completely trapped in the x direction between negative 5 and 4. So that's exactly how we write our domain. All my x's, sorry, I'm gonna write my other color. All my x's are between negative 5 and 4. Remember, double walls, double inequality, right? If you've got 2 walls, then your answer is going to be a double inequality or a compound inequality. And then these would all be less than or equal to's. Less thans because they're always less thans when it's a compound inequality because we're writing it from least to greatest. And equal to's because they're solid circles on each number. Okay, now the range is your low to high, right? Is this graph allowed to go forever down? No, because there's a wall right here stopping him from going forever down. And what is that y value? Negative 2. All right, then he's trying to go forever up, but he can't because he's being stopped right here. And that is a y value of positive 2. So that means all of my y's are trapped between negative 2 and 2. So my range is negative 2 is less than or equal to all the y's less than or equal to 2. Remember, least to greatest, floor to ceiling. He starts at negative 2 and he's allowed to go all the way up to positive 2, and that is it. And that is where it gets chopped off. All right, moving along. All right, looks like this guy is also not allowed to go forever left and right. We're definitely hitting walls. Let me make that. All right, so he's hitting this. Oh, sorry. Hold on. I changed the wrong one. Just give me a sec. There you go. I didn't want my highlighter super large. Okay, so we're definitely hitting a wall here. Oh, my goodness. Sorry. We're hitting a wall here. And it looks like that x value, if I zoom in and count that, that looks like negative 2 is that x value. And then we're hitting another wall. He's trying to go forever to the right, but we just can't make it. He's being stopped right here. What is that? 1, 2, 3, 4, 5, 6. That is an x value of 6 right there. So my entire graph is trapped between the x values of negative 2 and 6. So my domain is literally an x trapped between a negative 2 and a 6, right? Double walls, double inequality. And then these are always less than no matter what because we're writing from least to greatest. But we're not going to use equal to bars because these are clearly open circles. So that means those are just our boundaries and we're not actually including negative 2 and 6. There we go. All right, let's talk about range. Is this guy allowed to go forever down? Doesn't look like it. It looks like he's being stopped right here and he's being told to turn back around. So let's see, what is that y value? Negative 1, 2, 3, 4, 5. Negative 5 is this y value where it's crossing the y-axis. And he's also clearly not allowed to go forever up because he's hitting these open circles which are stopping his graph. And that is what a y value of 2. So my entire graph's height is trapped between negative 5 and 2, which means my range is a bunch of y's trapped between a negative 5 and a 2. Double walls, double inequality. Now, they're always less than symbols when it's a double inequality, right? But in this case, it's actually hitting the -5. I don't see an open circle there, which they're not going to put a big giant dot right there, right? If it's hitting the value and it looks like it's touching that, then you're going to put an equal to bar. But we're not clearly going to have an equal to bar up here with those big giant open circles, right? So we're going to leave that one alone. All right, almost there. Here we go. Let's do a couple more. Here we go, domain and range. It's the same thing over and over and over again. So domain, we're looking for, is he able to go forever left? Yeah, because this arrow is going forever left. So he has no wall on the left side. Is he allowed to go forever to the right? No, right? He's not. There's a wall right here stopping him, and that's clearly an x value of 2. So single wall, please remember this, single wall, there's only one wall stopping my domain. Single wall means a single inequality. So I'm going to just write x and then the 2, and then you've just got to figure out, is the graph less than 2, meaning to the left, or is it greater than 2, meaning to the right? Well, clearly my entire graph exists on the left side of this wall, which means that's where everything is less than 2. So that is our domain. And again, I'm not using an equal to bar because there is a dot there. If you zoom in, right, that's an open, oopsies, right, that's an open circle there. All right, range. Now this one's kind of tricky. You had one on your quiz like this as well. Is this graph allowed to go forever down? No. Please don't draw your wall right here though. I do not care that the graph stops right there because that's the graph, this is the stopping point that is affecting the width. It is not affecting the height. This is the wall affecting the height because this is the lowest he's allowed to go before something makes him turn back around and go the other way. Okay, so that is a y value of -2. Please be careful. It's very hard to see the negative because it's kind of blending in with the line itself, right? So just be really careful. You know it's a -2 though because you're underneath the x-axis, so you should be able to catch that. And then is he allowed to go forever up? Yes, he is, right? Because there's an arrow going up forever and ever and ever. So there's only one wall, so that means one inequality. So that means my y's are in some relation to -2. Now, notice the entire function is above that line. Well, does that mean it's greater than or less than -2? Greater than. If it's above the wall or to the right of the wall, it's greater than. If it's below or left, right, that's less than. Now, this one is going to get an equal to bar because is he equaling -2? Yeah, right, he's actually hitting that. There's not an open dot there. You have to physically see an open dot to not equal the value, and there's not one there. Okay, so that is our range. All right, I think this is our last one. Whew. All right, domain and range. Here we go. Is this guy allowed to go forever left? Yep, because it's going to keep getting, I know that looks more like it's pointing down, but it's kind of down and left. So he's going to get wider and wider and wider and wider forever and ever and ever, right? So that arrow is also moving left. So there are no walls to the left. And there's also no walls to the right because he's going to get wider and wider and wider this way too. It's going to happen very slowly, but it is getting wider. So it is going to hit every x value. So there are no walls, which means our range is all real numbers. Okay. And then of course for our range, is he allowed to go forever down? Yeah. There's arrows going forever down. So there are no walls at the bottom, but he does have a maximum. He's only allowed to go this high, right? And you've got to find that y value. Let's see, what is that? A y value of what, 3? So he's only allowed to max out at 3. So how do we write that? So it's a single inequality, so a y and a 3. And notice the entire graph is existing below the wall. Is that less than 3 or greater than 3? Less than. Or equal to, because it's actually got a solid dot and it's hitting the value of 3. Okay, and that would be our range. Oof, all right, that was a lot of domain and range problems. Okay, last topic was our sequences. I'm going to fly through this pretty quickly. So remember, when it says a sub 1, there's a lot of tricky notation here, but as long as you understand what it's saying, it's pretty easy to do these sequences. So remember, a sequence is just a pattern of numbers, right? Oh my gosh, this is asking for the 7th term. Okay, so I'm going to draw 7 blanks. 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to put, this is what I'm looking for. All right, that one is my answer. Okay, so here we go. It says, given a sub 1 is -3. But remember, a sub 1 means your first term. So that's telling you that this thing is starting at a -3. Okay, that's all that means, first term. All right, and then they're giving you the rule. They're saying a sub n equals a sub n minus 1, which is a whole bunch of jargon of just saying you get the next number by adding 6, right? That is your common difference right there, telling you what you're doing to get the next number in line. Sorry, I'm just writing all these little notes down. So we're going to take, to find a sub 2, we add 6 to -3, right? And what's that going to give us? 3. Then we add another 6 to that number to get the next one in line, which is going to give us 9. And we're just going to continue this over and over and over again until we finally get the 7th term, because that's the one they asked for. So what's this going to be? 15 plus 6 is 21, plus 6 is 27, plus 6 more, 33. And that's our answer because it asked us for the 7th term. Okay. All right, over here. Now this is the rules are the same. This is just function notation. So instead of writing a sub n, they're writing f of n, like, because this is the same thing as like f of x that we talked about earlier. So they're just writing it in function notation instead of a sub n form. F of n minus 1, that's the same thing as a sub n minus 1. It's absolutely no different, okay? All you really need to care about is that the -5 is the common difference. That's all you really need to know. That's all it's happening, sorry. Right? And they're also telling you what the first term in the sequence is. And then it says find the 3rd term. All right, so first term, second term, 3rd term, right? And this is the one they're wanting, so I'm just going to go ahead and box it up so I know what my final answer is and where I can stop, right? So f of 1, right? So this is f of 1, just like it was a sub 1 before. It's just a different way of writing it, is 9. And then the common difference is 5. So we're minus 5, sorry. So we're going to -5, which means my next term is 4. Then we're going to -5 again, which means my 3rd term is going to be -1. And that's it. That's my answer. Okay, you just have to know how to read the lingo, right, of those recursive formulas. All right, this one says write the recursive formula for the sequence. Well, remember there's 2 things that you have to be given, or you have to tell people when you write a recursive formula. You have to be given the first term. Well, out of these, which one is the first term? -1, right? So you're literally bringing down the first term. And then you need to find the common difference. What are we doing to get from one number to the next? Right? It looks like we're subtracting 3. So that is our common difference. Right? Our common difference is that we're subtracting 3, which means to finish off the formula, it's going to be f of n minus 1, because that's just how you write it for the function notation rule, and then -3 at the end for your common difference. Right? And this, all of that is the recursive formula for this sequence, right? Telling the reader what the first term is, and then telling them what the rule is, so they could create the sequence on their own if they wanted to. Okay. All right, last one. Write the recursive formula for this sequence, but this one is wanting the a subscripty rule. Same rules apply though. So they want you to write the a sub 1, which is clearly 5, right? This is your a sub 1 right here. And then your rule, well, I need my common difference first. So let's see, what are we doing to get the next number over and over and over again? Looks to me like we're adding 2, right? So plus 2 is the common difference. Which means when we write our rule, it's going to be a sub n minus 1 and then plus 2 hanging on the end to tell the reader what the common difference is. And that's it, right? That's writing our recursive rule. All right, pretty sure that was our last question. It was. All right, guys. So I'm hoping that helps and you found some assistance with any problems that you were struggling with. If you still have questions, you can, of course, come in for tutoring, but just make sure you're ready for that Unit 2 test. All right, see you guys.